In this example, we are going to be using a perimeter. And a perimeter is the measure of the outside of any polygon. So if we measure each side of a polygon, sum up those measures, that winds up giving us a perimeter. So this particular problem, it says that Andre just purchased 400 feet of fencing in order to install a rectangular corral for his horses. The length of the corral is twice its width plus 20 feet. Determine the dimensions of the corral. So that's what we need to do. We're going to determine the dimensions of Andre's corral. One thing I want to point out here is this is a rectangular corral. So I'm going to go ahead and I'm going to draw a rectangle here representing the corral, and you should too. And again, these don't have to be anything fancy, just something that'll lend a little clarity as far as what's going on. Now, a rectangle is a four-sided figure. It's known as a parallelogram. A parallelogram has opposite sides that are parallel to each other, as you can see here. And a rectangle is identified by these 90-degree angles. Its corners are 90 degrees, and I'm just going to put in these squares here. The opposite sides of a rectangle are also of equal measure. So if I mark this one with a tick mark, we can use tick marks just like we did for angle measures. And then put this one over here. That means that those two sides are of equal length. And then I'll do the same up here. I'll mark these with two tick marks. And that means that these two sides are also of equal length. So now I have this rectangle here. I'll mark this side here maybe as the width. And maybe this one down here is the length. Now for a rectangle, we can determine the perimeter. And I'm just going to mark it over here, P for perimeter. That would be equal to the length of the measure of this width right here. I would add that to the length, to the measure of this length right here. I would then add that to the measure of this width right here. And then, of course, I would add that to the measure of this length right here. We could then kind of summarize this by the perimeter is then equal to, we have two widths here, that's 2W, and we have two lengths plus 2L. So this equation right here generalizes the perimeter of a rectangle. So now as we read this, it says the length of the corral is twice its width plus 20 feet. Now, I don't know what its width is, but I do know what its length is in relationship to the width. And its length is twice its width plus 20 feet. So I'm just going to pencil it in like that. So now its perimeter here, since he's using 400 feet of fencing, that's going to be its perimeter. That's how long its perimeter is. So I'm going to put in 400. That's equal to 2W plus 2L. And what's L? Well, L is 2W plus 20. So now we can solve for W. So I'll write this as 400. That's equal to 2W. And now I'm going to use the distributive property. 2 times 2W, that's 4W. And 2 times 20, that's 40. We can now gather up like terms. 2W and 4W, that's 6W. I'll then subtract 40 from either side. These will cancel. 400 minus 40, that's 360. I'll then divide either side by 6. These will cancel. So then the width is 60 feet. So I'm just going to put that in right here. I'm just going to pen it in. 60 feet. If the width, W, is 60 feet, here it is right here. So this winds up being 2 times 60 plus 20. 2 times 60 is 120. And 120 plus 20 is 140. So the dimensions of his corral here is 60 feet by 140 feet. Now we're going to go ahead and we're going to check that. So I have the perimeter That's equal to 2W, and W is 60, plus 2L, and L is 140. 2 times 260, that's 120. And 2 times 140, that's 280. And 120 plus 280 is indeed 400. So it seems like it checks out.